Good morning, class of 2024. I am Ms. Gabelana, subject advisor for mathematics from Amatole East District. I just want to tackle a certain part in trigonometry as well, general solution. General solution of a tan ratio. Let me say, the question says determine the general solution of tan theta equal to 1. Of course, we are familiar with solving equations as early as in grade 10, but that's not a problem. The problem comes with a final solution of a general solution in a tan ratio. If it's tan theta equal to 1, what must we do? We'll do all what we know that we are supposed to be doing. What is it that we are supposed to be doing there? We are going to take tan theta and solve for it. Here is our solution. Tan theta is equal to what? 1. We are looking for general solution. Then, for the general solution, first part, the tan theta is having the coefficient of 1, which is very correct. Is having the coefficient of 1, which is very correct, and the ratio on the other side of the equal sign. What must we do now is to look for the reference angle. What will be the reference angle of the tan inverse of 1? It's none other than 45 degrees. Coming to the solution, the question says that we must look for general solution. Then that means we were not calculating for a reference angle is not the value of theta, but the value of theta will be where tan is positive. Because the ratio of tan, which is equal to 1, is positive. That means it's where tan is positive. No, it's not negative. I'm making a mistake. Then theta will be equal to what? 45 degrees plus 180 degrees times K. What is this 180 degrees for? This 180 degrees represents the period, is the period of the tan graph. If you still remember in grade 10, the tan graph is repeating itself after 180 degrees. It is repeating itself after 180 degrees. That's what it is meant by that 180 degrees. And for that solution, for us to just have theta equal to 45 degrees plus 180 times K, where K is an element of what? Of integers. For us to be correct, we must mention that K is not just any other value, but the element of what? Of integers. That is K. Then it's enough, it's fine for this solution to be like this, to have one solution where theta is equal to 45 degrees plus 180K. And then there is also another version for general solution of a tan ratio, whereby our tan will, instead of using 180 degrees, other people will be using 360 degrees. I want us to differentiate between the two, 180 degrees and 360 degrees. Even for 360 degrees, we will follow the same method up until here. Then when we are here, we will conclude by saying that theta is equal to 45 degrees plus 360 times K. What is this 360 now representing? Does this mean the period of a tan graph is 180 degrees and 360 degrees? No, the period of tan graph is 180 degrees. That is the period, this one. But for this one is representing a Cartesian plane, whereby our angles in a Cartesian plane are rotating at 360 degrees. Then if they are rotating at 360 degrees, this is the Cartesian plane that I'm talking about. 90 degrees, 180 degrees, 270 degrees, and 360 degrees. That is the rotation there in a Cartesian plane. The 360 means the full revolution in a Cartesian plane. And then what does that mean, Kengoku? It means that in which quadrants, if we're talking of a Cartesian plane, now we will be talking of quadrants. In which quadrants is tan positive? Our tan is positive in the first quadrant as well as in the third quadrant. That's where tan is positive. Then if you prefer to use 360 degrees, you can't stop at this solution. You must also represent a solution in the third quadrant, of which in the third quadrant, it will be theta is equal to what? 180 plus is 180 plus 45 degrees plus 360 times k, where k is an element of integers, even here, because if you haven't mentioned that k is an element of integers, you won't get all the marks. That is not the general solution, because you'll be meaning that k is any value of your choice, but 2k must be an element of integers. Then the theta in the third quadrant will be 225 plus 360 times k. Why is it necessary now? Why is it necessary now for two solutions to be appearing in this question when you are dealing with this question? It's just that in number 2, in my general solution, the first question said that determine the general solution of tan theta. Hence or otherwise determine the value of theta in the period of minus 180 to 180 degrees. It's not a big deal for the second question because you have already mastered the first one with the general solution. I want us to start with a solution layer, 180 times k, which is representing the period of the tan graph. Let us start with it for answering number 2. Number 2 will be, our theta will be equal to, we said that k is an element of integers. That means k can be 0. What if k is 0? What will be the value of theta if k is 0 there? If k is 0 there, it means that it will be 0 times 108 plus 45, which gives us 45 degrees. Again, what if k is 1? K is, we are substituting k now. We are substituting k by 1. That means it will be 1 times 108 plus 45 degrees, which will be 225 degrees. Okay, our interval was saying we were looking for the values of theta in the interval of minus 180 to 180 degrees. Then we have 225 degrees when k is equal to 1, which is already more than what? Is already more than that 180 degrees. It's fine. It's outside that interval of ours. Now let us go to negative numbers. Let's say now our k is negative 1. It will be minus 1 times 180 degrees, which is negative 180 degrees, plus 45 degrees. When we are adding 45 degrees there, which means our other angle will be equal to negative 135 degrees. Can we take k, which is negative 2? If we're taking k, which is negative 2, we'll have minus 2 times 180 degrees, which will give us negative 360 degrees. And negative 360 degrees plus 45 degrees will give us what? Negative 315 degrees. according to our interval. Our interval was saying between minus 180 and 180 degrees. Then we are fine for that one. We will stop at k equal to -1 because we are getting all what we were needing. But we don't need you 225 because you are greater than 180. And now we were looking for angles that are less than 180 degrees. Which angles are less than 180 degrees is 45 degrees and -135 degrees. Those are the angles that were needed for that question. Now I want us to move to the general solution with 360 degrees and one solution only. Remember here, we have one solution, that is theta is equal to 45 plus 180 degrees times k, where k is an element of what? Of integers. 45 degrees, according to what we know, is in which quadrant in grade 12? 45 degrees is in quadrant 1, in anti-clockwise direction. And what about -135 degrees? -135 degrees is rotating clockwise. In which quadrant? In the third quadrant, where tan is positive. According to the ratio of tan, tan is still what? Positive. That is, these answers are 100% correct. They are 100% correct. Our angles is 45 degrees and -135 degrees. Now let us take the solution, one solution of 360 degrees, not for both quadrants. When someone is using quadrants, when you see someone writing theta is equal to 45 degrees plus 360 times k, you must know that this person is using what? Is using a Cartesian plane. Is using a Cartesian plane. Then all quadrants must be shown and must be represented. Let us test by this one of taking one solution on the first quadrant, 45 degrees plus k, and check whether are we going to be able to get that 45 degrees and -115 degrees from this solution only. Okay, let us take it when k is equal to 0. When k is 0, it will be 360 times what? 0 plus 45 degrees, which will give us 45 degrees. It's fine. And then another angle, when k is 1, what about k equal to 1? It will be 1 times 360 degrees. 360 plus 45 degrees will be giving us what? 405 degrees. Okay, 405 degrees is far away from our period, which was from our interval, which was -180 to 180 degrees. Is not even closer to 180 degrees. Now let us stop with the positive k values. Let us go to negative k values. Now let us take -1. What if k is -1? If k is -1, we'll have -1 times 360, which is -1 plus 45 degrees. And it will give us -315 degrees. We're not getting that -135. Let us carry on. K equal to -2. It will be giving us -2 times 360. It will be giving us -720 degrees. And -720 degrees plus 45 degrees will be giving us -765 degrees. It's getting far away from -180 degrees. That is now, in which quadrant is 45 degrees? Is in the first quadrant. What about 405 degrees? Remember that 405 degrees is the second rotation in our Cartesian plane. Our full rotation is at 360 degrees. Then 360 plus 90, we're making a second rotation now. It's 450. It's 540 here. It's 630 here. Then it will close at 720 degrees. Then 405 is greater than 360, but less than 450, which means is also in which quadrant? In the first quadrant. Again, let us go to negative 360 degrees. For negative 360 degrees, we will have this Cartesian plane which is rotating anti-clockwise direction, in clockwise direction, whereby we will have the negative 360. Here we have minus 90, minus 180, minus 270, then we'll close by negative 360. Now let us look at negative 315. Negative 315 is on this side of negative 270. But negative 315 is more than negative 360 degrees. Is less than negative 270, but is more than 360, of which all the angles that are more than negative 360 but less than negative 270 are in the first quadrant. It means that even negative 315 is in the first quadrant. Same applies to negative 775 degrees. Is in which quadrant? Is in the first quadrant also. If you can do the second rotation clockwise direction, it will end there at negative 720. All these angles are in the first quadrant. That means if you are using 360 degrees, bear in your mind that you have to touch all the quadrants. Tan is not only positive in the first quadrant, is also positive in the third quadrant. Therefore, it doesn't work for 360 to have one solution only. It also needs the second solution, of which our second solution was the angle, the theta in the third quadrant. This one is in the first quadrant, and this one must represent the third quadrant. We said that in the third quadrant, that reference angle, which is 45 degrees, is giving us 225 degrees plus 360 times k, where k is an element of integers. You have already said that. And then when k is 0, what will be the actual value of our theta? It will be 225 degrees. When k is negative 1, what will be our actual value of theta? It will be negative 135 degrees. If k is negative 1, we'll have minus 360 plus 225, which is giving us negative 135 degrees. And then our interval, I'm always confusing the interval with the period. Our interval was minus 180 to 180 degrees. Therefore, the solutions, the angles that we need, Tina, for this interval is that 45 degrees and this negative 135 degrees. Therefore, your general solution, if you are using 360 degrees, must have two solutions for tan. But if you are using the period, of tan, it can have just one solution will cover all the quadrants. If you are using 180 as the period of what? Of tan. But if it's 360 as in the Cartesian plane, there must be two solutions. Tan is positive in the first and third quadrant. That's what I wanted to clarify. 2024 candidates. Hoping that you'll make it you'll make it in your paper 2 examinations. I wish you good luck, but good luck doesn't work if you don't practice. Practice, 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 and practice. And do ask the questions from your teachers from now on. Thank you so much. Bye bye. See you next time.